All right, y'all. Let's see. So I have a piecewise function. Today we're talking about piecewise functions. Piecewise functions are functions made of pieces. So it says a function that has different rules for different parts of the domain. Domain, again, is x values. So as your x values change, as you move along your x-axis, the rules to follow, the functions, change. So we're going to look at like this one. I start off here. This is a horizontal line. From here to here, x equals 1, 2, 3. This is -3, 4, 5, -5. So if I was to look at this graph, I would think that from x equals -5 to x equals -3, our function, if we were to look at the algebraic expression, the equation, would say to have a horizontal line. And then you notice that your function changes. And now I'm doing this. I have that little baby parabola. That's from x equals -3 to x equals like 1.5. So I would say from x equals -3 to x equals 1.5, we are a bit parabolic. And then last, if you look here, this portion changes again. From 1.5 to 2, 3, 4, 5. We have a line with a negative slope. So you notice that as you move across your graph from left to right, or move across the y-axis from left to right, I should say, x-axis, not y-axis, x-axis from left to right, your function changes. Different rules for different sets of numbers. To kind of adjust, this is not what you're going to see. You're not going to see from x equals -5 to x equals -3. You're going to see small number is less than or equal to your x. That is also less than or equal to -5. This tells you x is between, and in this case including because of the equals, -3 and -5. Oh, I have that backwards. Small number first. Always want to put your small number first. X equals -5 to x equals -3. I'm writing 5 again. Wow, great job. You always want to go small to big because this is a less than sign. So this is literally saying x, -5 is less than or equal to x. So x is bigger than -5 or equal to it. And x is also smaller than -3 or equal to that. This one, we always want to go small number, would be -3 is less than or equal to x is less than or equal to 1.5. They couldn't both be equal to, but based off this graph, you can't really tell which one it is. And then this one would be from 1.5 to 5. So always small and then big. So small number, less than or equal to variable, less than or equal to big number. That's how you write that interval. Okay. We're going to do some practice with it. We're going to graph and we're going to just evaluate. So here's how it will look. This tells you what to do on the left. This tells you when to do it. So what that means is when x is less than -1, do y equals x plus 2. So you know your x's, anything smaller than -1. When you are on that part of that line, so anything to the left of here, less than -1, will follow this function. X plus 2. And then here, this is when x equals -1 to x equals 1, do y equals 1. So from -1 to 1, that will be the function that I do, y equals 1. And then the last one is when x is greater than or equal to 1, do y equals 2x minus 1. So the right side tells you when to do something, and the left side tells you what you're doing. This gets the y value. That's your y equals. I feel like that sentence doesn't really make sense. I'm going to erase that. But this produces a y coordinate. This is your x coordinate. So we're just going to do that. We're going to plot some points. It has some starting values. I do need to know where this function begins and where this ends. So I'm going to look at my first piece. X is less than -1. When x is less than -1, do y equals x plus 2. So I'm going to find out where this would begin. Since it's just less than and not equal to, we would use an open circle here on the graph. You'll see what that means in just a second. Then I'm going to plug them in. When x equals -1, let's see what y would be. -1 plus 2. Y is equal to a +1. That means at -1, +1, I would have an open circle. Open circle because not equal to. Okay, and then obviously there's more numbers than just -1. So I'm going to pick a number less than -1. Let's pick, I don't know, -3. Random number, completely random. Y would be -3 plus 2. Y is -1. So at -3, I'm going to get a value of -1. Now, takes 2 points to make a line. There we go. That is that portion. You move on to your middle piece. From x equals -1 to x equals 1, do y equals 1. So weirdly, this stumps you guys. I don't know why. At every level, this always takes a second of thought. But when x equals -1, y has no choice but to be 1. When x equals the other side, +1, y has no choice but to be 1. Because this is saying no matter what x is between -1 and 1, including -1, not including 1, this one would be open circle because not equal to. This one would be closed circle because it is equal to. Equal to versus the not equal to. That's not there. You have no choice but to be a solid straight line. So at -1, at x equals -1, my y value would be 1. So I'm going to actually close in that dot. That's cool. And at x equals 1, y equals 1. So I got an open circle there, and then I'll connect them. No matter what you are between -1 and 1, your y value is a +1. And now for that bottom piece, the green piece, this is from when x is greater than or equal to 1, do y equals 2x minus 1. So I'm going to start at 1. You always want to start at the given value in the piecewise. When x equals 1, y is equal to 2 times 1 minus 1, or also 1. So I have 1, 1, so I'll close that in. That does not happen every single time. It just happens in this example. And again, I've got to choose a number bigger than 1 because it's greater than 1. So let's go ahead and just choose 3, be uniform. 2 times 3 minus 1, y is 5. So we've got 3, 5. 1, 2, 3, 4, 5. And I'm going to connect that. And that is what my piecewise would look like. So that's how you get different segments of your graph behaving differently because it's a piecewise function. We don't typically graph them just because we don't graph a ton of lines in here, but I'll probably have you practice it more. We evaluate, so that's what's going to be next. When you evaluate, you just get a value. So all of these are f ofs. This is my piecewise. My palm just drew a smiley face. My piecewise is given to me. This is x is less than -3, between -3 and 5, and greater than and equal to 5. When x is this, do y equals this. I'm gonna erase that. Okay, but that's how you know what you're doing when. I'm gonna rewrite that. All right, so f of, my f ofs, this is saying when x equals 0, inside the parentheses, my x here got replaced with this number 0. That's going in for x. When x is 0, what is y? So first I have to see what piece x equals 0 lays in. Erase those. X equals 0 will be between -3 and 5. X equals 0 included here. Because this is the piece that covers from -3 until +5. 0 happens in between there. So that means I'm going to use that function. F of 0 would be 3 times 0 plus 8, which is just 8. F of -5. Again, now my x value is -5. I want to know what y is. I'm going to erase these so I can do my new number. X is -5. This is the piece where x will be less than -3. So that would be -5. So -5 is included here, so I'm going to use that function. -5 plus 4, which will give me -1. And then this is saying x is equal to +5. What is y? So here's where I have to be careful. This middle segment does not have an equal to. That is just less than 5. I actually have to use that segment on the bottom. This will give me x equals 5. So I'm going to follow this function now. So I'll get -2 times 5 squared minus 5 plus 3, or -2 times 25 minus 5 plus 3. -50 minus 5 plus 3 would be -55 plus 3, or -52. And that is how you evaluate a piecewise function. If we were in person, I would have you try these. If you want to go ahead and try them, I'll quickly go through them. X equals -2 will follow here. Oh, there's a typo here. That should be a -5, not a +5. Ooh-hoo-hoo. I'm way too far into this recording to start over. So consider that a -5. Sorry. And when x is -2, now I don't fall in there. I fall in right here. That would be between -5 and 0. So I'm going to fall in there, and I would have 3 times -2 squared minus -2 plus 1, or 3 times a +4 plus 2 plus 1. 12 plus 2 plus 1 would be 15. Here, x, oh, different colors so that you can tell what I'm doing where when I post this without a recording. Here, this is x equals 5. Here, x equals 5, greater than 0. 5 is definitely greater than 0. So I've got -2 times 5 to the third. I don't know 5 to the third off my head. I think it's 125. Yeah. -2 times 125 is 150. 250. And a -250. And then last is f of 0 would be other color again. Other x equals 0 would fall in right here also, x equals 0. So I'll use that function, which is 3 times 0 squared minus 0 plus 1. So I'll just get 1. I know I went fast there. Pause it, try it yourself. This would have been where I stopped and let you guys practice on that. All right, now arithmetic sequences and series. You do these in Algebra 1. I'm splitting this up into 2 days since I'm not there. But you do these in Algebra 1. A sequence is a list of numbers with a definite pattern, like even numbers, 2, 4, 6, 8, 10. They all add 2 to get from one number to the next. This one, from 3 to 8, I added 5. From 8 to 13, I added 5. From 13 to 18, I added 5. From 18 to 23, I added 5. I could figure out my next number, it would be 28. And then I could figure out my next number, it would be 33. And you could go on and on and on because it is a pattern. That is what a sequence is. There is a constant difference, you can tell what your numbers are changing by, between each term. So you're either going to be adding or subtracting. To get from one number to the next. So here's our general rule for an arithmetic sequence in series. Since it changes by a constant value, a constant difference, that is considered a slope. This is actually just y equals mx plus b, right? This is your m, this would be your x, this would be your b. So this is actually just the equation of a line, because again, it's being added over and over or subtracted over and over, so you have the same change between each number. That is a line. So this is the equation we use to represent some sort of a pattern. I'm going to define these numbers for you, or these letters for you. We've got a sub 1, which is the first number in the list or in the sequence. And then we've got D, which is your common difference. And then you've got, just stop with me. There we go, okay, now it's back. Which is your common difference. And then we've got n and a sub n, and kids always get these backwards. N is the location in the list. Like, if we go 2, 4, 6, 8, 10, this would be n equals 1, n equals 2, n equals 3, n equals 4. N equals 5, whereas a sub n is the value of the number in that location. So what that means is that 2 is a sub 1, 4 is a sub 2, 6 is a sub 3. 8 is a sub 4, 10 is a sub 5. So the n tells you what number you are in the list, the first term, the second term, the third term, whereas a sub n is the value of that number in the list. So number of term, I'll use that word term a lot, nth term. Okay, so this is your general rule. I'll write this equation bunch for the rest of the lecture. We actually have 2 slides, so it's not that many questions, but that's okay. All right, here we go. We got 3 on 1. It says find the 12th term in the arithmetic sequence. I've got a sub n equals a sub 1 plus n minus 1 times b. So find the 12th term. This is number of term, location in list. So we already know n. N is equal to 12. I know my first term. I can see that right here. Number 9. I can figure out what my common difference is. From 9 to 16, I add 7. From 16 to 23, I add 7. From 23 to 30, I add 7. So D is equal to 7. So as of right now, I know N, I know D, I know a sub 1. I am looking for the value of the 12th term. So I'm looking for a sub n, which in this case is a sub 12, because it's the value of the 12th term. That's my goal. Find that. So I'm just going to plug everything in my equation. A sub n is equal to a sub 1, 9, plus n minus 1, 12 minus 1, times d, 7. 9 plus 11 times 7. Careful with your order of operations here. 9 plus 77, 86. Again, I know I'm going quick. This is a recording. Pause it. Work at your own pace. Next, write an equation for the nth term of an arithmetic sequence. So nth term means it can work for any term. This is the general formula. I only know a few things. I know my first term, and I can find out what my common difference is. 5 to negative 13, negative 13 to negative 31, we are subtracting 18. That is how you get from 5 to negative 13 and then negative 13 to negative 31. D is equal to negative 18. That's literally all that we need to write our nth term equation, because this works for any n. On a quiz, I typically ask you to write the nth term equation and then give you an n. Write the equation. Now find some obnoxious term like the 113th term or something crazy like that. So I ask you to write the general equation, and then you can find a specific value from that. And last here, write an equation for the nth term of the arithmetic sequence where, a sub 5 is equal to 19 and d equals 6. So if I'm writing an equation for the nth term, again, I want that a sub n equals a sub 1 plus n minus 1 times d, and I want it to work for any n. So I only need to know a sub 1 and d. I already know d. I do not know a sub 1. So I'm going to have to find a sub 1. Here's where the puzzle pieces come in these things. That's really all arithmetic sequences and series are. It's a pattern, it's a puzzle. You're looking for a missing piece. So right here I need to find a sub 1. I know a sub 5. In this, n would be 5, right? A sub n, 5. So I'm going to have a sub 5 is going to equal a sub 1 plus 5 minus 1 times d. I know I can plug in some stuff there, but I want to just make the connection right here between n and n. Those should match. Your nth term is also the n here. So I have 19 is equal to a sub 1, that's what I'm looking for, plus 5 minus 4 is 1 times d, which is 6. So I have 19 equals a sub 1 plus 24. Solve for a sub 1. 19 minus 24 is going to be a negative 5 equals a sub 1. Now write nth term equation. Again, this can work for any n. So I'll have a sub n is equal to a sub 1, negative 5, plus n, any n, times d, 6. You can distribute and stuff if you'd like, but it's not necessary. And last, I've got this where we find the missing values. So I want to fill in my blanks here. If I want to go from here to here and then here to here and here to here, I need to know what d is. So again, we only know one equation so far. A sub n equals a sub 1 plus n minus 1 times d. I know my goal is to find d. That means I've got to know the rest. If this is what I'm looking for, I have to have all of these. I definitely have a sub 1. That's right there. Negative 10. I also know here n is equal to 1, n equals 2, n equals 3, n equals 4, and n equals 5. I'm going to rewrite those. They don't fit well, and I'm going to erase this. So this would be n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. So I know n is 5. I have 5 terms there, so I can let n be 5. which means I also know a sub n, right? A sub n is the value of the fifth term. A sub n, which is a sub 5, is 2. Sorry, it's my palm. So now I'm just going to plug those into my equation. A sub n, 2, is equal to a sub 1, negative 10, plus n, 5, minus 1, times d. D is what I don't know. I can easily find d here. A little bit of arithmetic. 2 equals negative 10 plus 4d. Solve for d. Add 10 to both sides. 12 is equal to 4d. And now divide by 4. So d is equal to 3. Now that I know what d is, I can add, oh, I'm not going to erase those. I'm going to just write a new one. 1, 2, 3, 2. I'm just going to add d over and over, right? I know d is 3 plus 3, negative 7, plus 3, negative 4, plus 3, negative 1, plus 3, 2. We did it. Good. All right. So that is really the extent of it. We will pick back up on this when I come back.